Okay, so I've got this list of pairs of ions here, and we're going to create formulas for these. Okay, I've got these lists of pairs of ions, and we're going to create formulas for these. And so we said the first thing that we are going to do is figure out what the charge on each thing is. Okay, and so the way I've set this up, the thing on the left, the component on the left is the cation, the component on the right is the anion. Cation's the positive one, the anion's the negative one, the cation is the metal, the anion is the nonmetal, or there may also be polyatomic ions. Okay, so in looking at these, I have to first figure out what the charge is going to be. And so right away with NH4, I recognize that it is a polyatomic ion, right? It's not an element that I have that's a metal. It's a polyatomic ion. And I know if I go to my polyatomic ion table and look at it, it will be the ammonium ion, and it will have a 1+ charge. So this whole group is called ammonium. You won't find it on the periodic table. You don't have to think about nitrogen or hydrogen. As a group, it's the ammonium ion, and it has a +1 charge. Okay, let's make that a little better. And actually, yeah, so +1. And then oxygen is in column 6A, and it's a nonmetal. And because it's in 6A, it has 6 valence electrons. I'll need 2 more to fill its outer shell. That means I'll have a -2 charge, or I could just subtract 8 from 6 and get -2. Okay? Now, what I need to do is see how many positive and negative charges I have and how many I need to make them balance. Okay, so right now I have a -2 charge on the oxygen, and I can just reason that I'll need 2 NH4s to make +2. So if I've got a -2 here, I'm going to need 2 NH4s to make it a +2. Or I could just switch the numbers. I could put a 1 after the O and a 2 after the NH4, and it's going to do the same thing for me. And so what the formula is going to end up being is NH4 to oxygen. Okay? So that's how we do this. Now, for rubidium and phosphorus, I find rubidium, it's in an A column, it's in a 1A column, and I automatically know since it's in 1A, it gives up 1 valence electron, and it's going to have a +1 charge. I find phosphorus in column 5A. That means it has 3 spots for receiving electrons, and if it takes those 3 spots, it's going to have a -3 charge. Or I could just subtract 8 from 5 and get -3. So it's got a -3 charge. And again, this one's fairly simple. I can simply reason that I will need 3 1+ to balance 1 -3. That would give me 3 negative and 3 positive charges, right? So that will be the number of rubidiums that I have, Rb3p. So that's going to be the formula. Okay? Okay, so just wanting to see how I can move this. So I'm going to have to do this. Okay, so next I have aluminum and iodine. And again, both of these are in A columns. Aluminum's in column 3A, so it's a metal and it's in 3A. That means it's going to have a 3+ charge, or a +3 charge. Oops. And then iodine is in column 7A, and everything in 7A has 1 spot available for an electron to fill it, and if that happens, then I'm going to have a -1 charge. Oops, not a -4 charge, but a -1 charge. And if I, again, just simply reason, I'm going to need 3 -1s to balance 1 +3. So this, in this case, I'm going to have Al except I can't draw an Al, and then 3 iodines, okay, Ali3, okay? So that's how this works. Okay, now calcium and sulfur. If I look up calcium, it's in column 2A, and that means it'll have a +2 charge, right? And then sulfur is in column 6A, and since it's in 6A, it has 6 valence electrons. It means there's 2 more spots available, and if it takes those 2 valence electrons, it'll have a charge of -2. Now this is a situation where they're both the same number. They're already balanced, so I only need one of each of these to be in my formula. So I'm just going to say CaS, and that's my formula. Cesium and fluorine. Cesium is in column 1A, so it's going to have a +1 charge. Fluorine's in column 7A, which means it's going to have a -1 charge. I can just subtract 8 from 7 and get -1, right? Or I can remember that anything in 7A has 7 valence electrons, and I need 1 more to fill that spot. Again, I have the same number of charges here, so all I have to do is just say I need 1 cesium and 1 fluorine, and the charges balance. Okay. Here I have magnesium, and then I have one of my polyatomic ions, right? So for magnesium, I know that's in column 2A, so it's going to have a 2+ charge. And magnesium, or I'm sorry, hydroxide, I'm going to find out has a -1 charge if I go to my polyatomic ion table. And I can reason that I need 2 OHs, okay? The whole group, not just O, not just H. I need 2 OHs. And if I need more than one of a polyatomic ion, I put parentheses around it to accomplish that in the formula. So what we're going to say is Mg, and then I put parentheses OH, and I have 2 OHs, right? So that's that formula. Strontium and selenium. Strontium, I will find out, is in column 2A. So it's going to have a +2 charge. Selenium is in 6A, and if I take 6 - 8, that's -2. Or I could remember that selenium has 6 valence electrons. It needs 2 more to fill its outer shell. If it takes those 2, it'll have a 2 negative charge. Again, another circumstance where they're even already, 2 + 2 and -2, so I just need one of each of these. So Sr, Se is the formula for that. And I can look at this and say, well, strontium was in column 2A, barium's in 2A, selenium's in 6A, tellurium's in 6A. I know then that this is going to have a +2 charge, and this is also going to have a -2 charge, just like selenium. And so I only need one of each of these again. BATE. Oops, not little t though. So barium telluride. Okay, and then I have sodium in one of my polyatomic ions. Sodium's in column 1, so it'll have a +1 charge. Nitrate has a -1 charge. If I looked that up on the polyatomic ion table. So this is already balanced. I need 1 sodium, and I need 1 NO3. Now I don't have to put parentheses around that because I won't have a confusing subscript after NO3. Okay, just figured out that my program, for some reason, again, is going to limit me to 10 minutes here, so I'm going to have to stop this recording and one last small recording. Okay, stop this.